What happens when an AI agent learns something it shouldn't remember? Imagine a reinforcement learning system trained across multiple environments, but one of those environments contains sensitive information that must be erased for privacy compliance. Building on that challenge, the core problem is that reinforcement learning agents don't just process static data. They memorize features of the environments they interact with, creating privacy risks that existing unlearning techniques cannot address because those methods weren't designed for the dynamic, sequential nature of reinforcement learning. The authors introduce two innovative methods to tackle this problem head-on. The first method, decremental reinforcement learning, works by having the agent randomly explore the environment it needs to forget, while training with a loss function designed to minimize its effectiveness there. The second approach, environment poisoning, takes a different angle by strategically modifying the environment's dynamics to mislead the agent during retraining. Diving deeper into the mechanism, decremental reinforcement learning essentially teaches the agent to become worse at the environment it needs to forget. Through iterative fine-tuning over multiple epochs, the loss function systematically reduces the agent's ability to accumulate rewards in that specific environment. The authors validated their approach across diverse real-world scenarios. The results showed a clear reduction in the agent's performance on environments targeted for unlearning, measured by cumulative reward metrics, while crucially maintaining effectiveness in all other environments without any degradation. This visualization shows the effectiveness of the unlearning process through inference attack results. What we're seeing here is that after applying the unlearning methods, adversaries attempting to infer information about the forgotten environment have significantly reduced success, providing concrete evidence that the agent has genuinely forgotten, rather than simply suppressing its knowledge. And, 10 words of footfall. Looking at the boundaries of this work, the methods have been validated primarily in discrete environments. Extending these techniques to continuous control tasks represents an important next step, along with developing more sophisticated ways to differentiate between similar environments and establishing standardized metrics for evaluating unlearning effectiveness. This research represents a fundamental shift in how we think about privacy in reinforcement learning, by demonstrating that agents can selectively forget entire environments without compromising their overall capabilities. The authors have created a foundation for developing AI systems that can comply with privacy regulations while maintaining their utility. Reinforcement unlearning opens a new frontier where AI systems can honor the right to be forgotten while continuing to serve their intended purpose. Visit emergentmind.com to explore more cutting-edge research in privacy-preserving machine learning.